Let's give my new pump drill a try. Not quite yet. Pretty sure we got an ember here. Maybe I should point out that I'm working with ash. This is nicely seasoned white ash. It's pretty hard stuff. Takes a while to generate dust with these real hardwoods. And sometimes what I found is it's good to sort of prime the pump. It's sitting over there somewhere. I used some ground up cracked cap polypore, the shelf fungus that you find on black locust trees just about everywhere. Put that down into the V-notch, and it doesn't require quite as much dust generation before the ember ignites. It's pretty helpful. All right. A bird's nest is some inner bark from a cottonwood tree. I found a broken limb a few days ago. Thought I'd bring it home with me. Nice big fat ember. All right. Reposition. The wind's blowing smoke in my face. There we go. All right, my brand new pump drill, ash bit, and footboard works just fine. How about that? I have resisted making a pump drill for a really long time. My first reaction when I saw a pump drill was that it was an unnecessarily complicated contraption that didn't seem to offer a lot of advantages over, say, a bow drill. Some people would say that maybe it's easier to learn how to use a pump drill than a bow drill. Time will tell. The only people that have played with my pump drill other than me are also firecrafters who know how to drive a bow drill. So as I let additional scouts and others play with this who are novices, we'll see if learning the pump drill is actually easier. But as I was studying the pump drill, I came across several references of modern pump drills that are used in the jewelry industry. Real small, fine drill bits, 1/2 millimeter up to maybe 1 or 2 millimeters. Some of these pump drills that are used in the jewelry industry are fine instruments in themselves, probably made by the jewelers who use them in some cases. And being an engineer, I got intrigued by that. I like tools, and I thought maybe I would build a nice one. This is by no means a fine work of art, but it was inspired, if you will, by some of the pump drills that jewelers use. And in particular, it's got a drill bit chuck down on the bottom. My drill bit is not really a drill bit. It's just a, in this case, it's the piece of ash that you saw me use a little bit earlier. I whittled it down to, this is a 1/2 inch drill chuck, and I whittled the nub down to a 1/2 inch. This drill chuck is a Jacobs drill chuck. I got this off of eBay for $7.90. I'll post a link to it. I can't speak to the overall quality of the chuck for its intended purposes, but for a pump drill, it's really quite magnificent. My shaft is a solid oak dowel rod, and in the base of this drill chuck is a recessed threaded hole. It's about 3/4 of an inch deep, and I don't know what the threads per inch. I think it's 20 threads per inch. It doesn't really matter. But what I did was I used a sharp chisel and a wood file and some sandpaper and worked my 5/8 dowel rod down to a 1/2 inch, and then just screwed the drill chuck on hand tight. It's not going to come off. The flywheel is a cast iron caster wheel that I got at Menards. I think I paid $16 for it. It weighs about 2.5 pounds. And as you can see, most of the weight, a good bit of the weight, is on the outer ring, which increases the moment of inertia and the stored kinetic rotational energy when this thing is pumping. It's really quite aggressive. Overall, the whole pump drill weighs a little over 3 pounds. The cross piece is just a leftover piece of 1x2 pine that was left over from a project my daughter Maria and I worked on last year. We made a charred, distressed wooden American flag that we have hanging up in the basement. This was a leftover piece of that. In the overall geometry, I've been asked about that from people I've showed. The overall geometry, I didn't make this up. I can't say that this is optimum geometry in any way. I've done no math to prove it. It just seems to be very popular, and I found a lot of references to it. And it's a 3, 4, 5 triangle kind of geometry. It's 3, 4, 5 geometry. Just to give you some references, if you're interested in building something just exactly like this, oh, by the way, my string is just 550 paracord. I had some purple paracord left over from another project, and so I thought it made it look real nice. If you're interested in building one just exactly like this, I put my hole for my paracord 1 inch from the top, and I adjusted everything so that there's 2 inches from the top of my flywheel to the bottom of my pump rod, my crossbar. It's 3, 4, 5 geometry, and from this hole right here to that hole right there is 20 inches. I think that's sufficient for you to back out the rest of the geometry of the problem. It's really been fun to play with. I'm kind of inspired to look more into pump drills. I think my next one is going to be something I make out of a stone and maybe a tree limb or something straight that I find in the woods. I'd like to make one with found materials next. So stay tuned. We'll see how that turns out. But anyway, it's been a fun project. Works quite well. It's really super aggressive and actually worked quite nicely with my real hard seasoned white ash. Hope you enjoy it. See you soon. Have a nice evening. The cicadas are out in full force today. Can you hear them? The stuff I've got here in my hand is known as cracked cap polypore, sometimes also known as shelf mushroom or shelf fungus. It grows on the side of black locust trees here in southwest Ohio and lots of other areas. Get yourself a piece of this stuff, let it dry really well, grind it up into a fine powder. What you can do is place this into the notch of your hearth board, and that will aid in ember ignition sometimes when using harder woods in your fire by friction kits. Give it a try sometime, see how it works.